Hi, today we're in my lab at the university and we're going to tear apart this Bruker Avance 300. This is the control cabinet for a NMR, a nuclear magnetic resonance device. So this is two parts. There's a big superconducting magnet where you lower the sample in, and then this is the heart of the machine where all the electronics are housed. And this is actually an old NMR that my university is throwing away. And when I saw that they were chucking out their control cabinet, I asked them to put it aside so I could tear it apart, find out if there's anything worth salvaging in here, and there really is going to be quite a lot worth salvaging in here. These things, brand new, were hundreds of thousands of pounds to millions of pounds. I'm not sure about this particular model, but certainly it wasn't cheap. And you're going to see they spared no expense in making this system. I mean, just the cabinet itself, if you look from the outside, it has this anti-static mat that clips in at the top. Just that kind of touch tells you that this thing's expensive. And if you look at this front door, because we'll come in and look inside the cabinet, the first thing you see is there is a RF gasket around the outside here. So there is actually all the way around the door, there is a metal seal, and there is a vent on the front here. Let's try and take this off. There we go. So even this whole vent has a lot of metal across it to provide RF shielding. And you can see there's no real direct line of sight through the door either. So, I mean, this thing has fantastic RF shielding. So it's going to be full of goodies. Okay, so let's start at the front. First of all, look at that power switch. God, that's got some good. Actually, feels momentary. Right, so actually that's not gonna actually do the power switching. It's gonna connect back through to the back to trigger some relay in the back there by the feel of that. Yeah, what do we have? We have a lot of stuff. So first of all, again, you can see careful grounding everywhere, and that RF gasket that we have around the outside. And this amazing locking door that provides pressure both at the top and the bottom, just to make sure that that seal connects at both sides. Well, we're already quids in. There's a earth bonding point. Nice. We've got an anti-static strap. Normally the way these racks are built is that you have kind of a control system on the left, and then you have kind of building complexity from left to right. It's just the way that they kind of put them together. It doesn't, yeah, do you know what? That looks like the case here as well. I see an Ethernet here, cable. Yeah, you can see it says F-ETH. And underneath it says host. So that red cable seems to be how you would control this system. And then we've got the kind of progression from left to right. Over here, this seems to be the output, because we have two of these high power RF connectors. I think these are N-type, if I'm not mistaken. And yeah, look at these cables. Look at the shielding on them. So this probably goes off to the superconducting magnet, that main chamber. And there seems to be two other cables here that come in. What are they? Aux out. Okay, so that must be like a smaller coil that they modulate. Down at the bottom, we seem to have some more RF cards, and then something that says 16-bit. So I'm guessing these are ADCs, and these aren't, that isn't RF shielding, that's plastic. So I'm guessing this is probably something like measuring the temperatures or other systems. I think probably the main ADC is here. So this will be a really interesting card to look at. So let's look at the back. Oh no, oh, you hate to see it. So the way they remove this is they just cut these cables, and these cables were probably worth, you know, hundreds or thousands. I mean, high power RF cables in scientific systems. Yeah, that's a real shame to see. So we see a nice Ethernet connection to different devices. So this is the host. Look, they couldn't even be bothered to unplug the Ethernet. Just chopped the whole thing off. That's terrible. Yep. So helium level. Okay, so this is all of the kind of alarms. Spin, lift, temperature, temp. I wonder why there's an air hose for temperature. Yeah, you just have to push these things and you can withdraw the hose. Why they didn't do that, I don't know. And look at the input filtering. I'm expecting amazing input filtering on this system, because given how, you know, how filtered this case is, you've got to filter the mains coming in. So you have an input breaker, 216 amp, and then it looks like we have a, yep, okay, so this is a transformer, so it's give us 24 volts. No idea what this is. doesn't come out. Okay, we'll go attack that later. Here's the relay. Okay, so I'm guessing this is the thing that switches off and on when we press the switch at the front. And then we've got a breaker for the work table and a work table. So I'm guessing you do something else up here that requires power. Okay, let's try and open this up. Again, more of this gorgeous shielding. And here's the back of those two racks. So again, we see, wait, this is like a dual-ended rack? How long is this? Ah, okay, we might actually have two racks here. Yeah, we have a rack in the front and the back. Look at this mains power section down here. We seem to have some kind of temperature sensor. Oh, it says PT100 as well. So there's going to be a nice temperature sensor in here somewhere. Okay, it seems they made a really strange decision here, at least on the input mains. What you can see is all this input filtering and the mains control there, but then it seems that it went out of this, so it kind of comes in, then out again, and then back in through this kind of section down here, right? And that comes up into this hazardous area, which seems to be the distribution for a lot of the mains electricity. So a lot of these cables are hardwired, these spiral cables are hardwired into that. So at least we're figuring out how the mains gets in. One of the things I've been removing is the pneumatic system. So we've got quite a few pneumatic fittings in here. I think there's even a pressure regulator at the front that I'll get out next. But we'll just strip this apart. There's a couple of sad things as well. So this is a beautiful, you know, that's got to be a thermocouple, but it's a grounded thermocouple. Yeah, that's nice. I wonder what the chemistry is of that one though. Oh, it's a T-type. So we'll be able to figure out what the temperature range that was used for. Now, this looks like whoever salvaged the exit cables ruined this thing, but one of the nice things about thermocouples is you can just make them, the cable that they are actually made out of is the cable that you make the thermocouple out of. So you could just electrically weld these two together, and I've now got a T-type thermocouple. It's a shame it's not S, because the S is made of platinum. So we would have had a nice payday there just from that. Okay, back to the teardown. Let's get some more of this out. There's a nice pressure regulator down there. That's something I want to kind of get out and salvage. I just managed to kind of pull out this cable, and I was just kind of admiring it. So you can see they have this really hefty kind of shielding that starts like halfway underneath, pretty much where this ended. But look at this breakout. Look how many things they were sensing. And then these connectors, this termination is just crazy. So, I mean, they look gold plated, but what kind of got me about this was, look at this kind of detail. There's some kind of prismatic window up here. And this screw, look how complicated this is. I mean, there's a circlip in there. I can't help but feel that this was an extender placed onto a nut to extend it. So I don't know, you know, you'd think you'd just build a new one. So this is a kind of cute thing I've never seen before. So there's these little kind of clamps that hook onto this tray here and is used to kind of strain relief and maybe even ground these shields, because I haven't seen the shields attached anywhere. But yeah, that's kind of cute. Anyway, I'm holding out a lot of hope that there's some really nice gas equipment in there that I might use for the Enos project. So we're a bit further into the teardown. Managed to remove a lot of the cables going backwards and forwards. Found a couple of kind of interesting things. Down this side here, there seems to be some kind of plastic bottle that was part of the gas system. Maybe a knockout bottle to catch dust. We managed to get the mains distribution, one of the mains distribution units off. And you can see this is a socket. It's pretty standard wiring. There's a pretty nice Schaffner input filter there. But I think we're at the point where we're going to take, actually, instead of trying to take racks out, we're going to take card by card, and I'm going to start on the right and work my way left. So we'll start with the RF output. I'm a little bit worried that there might be something beryllium based in here, so I'm going to be a bit gentle with this. I'm probably going to rescue these terminations, because they're always, you never have enough SMA terminations. So now we're getting to the interesting stuff. I've removed that entire RF section out of there, and the first thing I noticed is the cards aren't even length. And that's when I saw this abomination back here. I mean, look at that, a riser card for the back panel. It looks like maybe they've taken something for a different, like shorter rack and then adapted it for use in here. But you can see this back panel is custom anyway. So you can see we have kind of a change in the bus. There seems to be, oh wait, does this bridge? This might be a bridge card between the two back panels. So you can see that there's a line there. I mean, that could also be a separation of the kind of RF ground and the digital ground, because you can see here we've got a nice socketed i960. I wonder what that is. Wow, that's a beautiful card. We're gonna have to get that out later. Yeah, so it might be that this card somehow bridges between the two sections, but I mean, what a custom thing. I mean, you'd think they would just extend the cards to the back. I don't think they saved any money doing that. But yeah, very cool. So now we have the kind of output chain up here. You can see that this top card has two channels, the two main channels, and that is clearly a power amplifier by the size of that enormous heatsink on the back. So I think what we'll do is we'll pop the cans off this one and have a look. Okay, so we've popped the cans on those. Kind of interesting, they didn't just use one board twice, they actually made two boards that were mirror images of each other. You can see the output stages. I think these are the final amplification stages here. I'll have to check what they are. Philippines BLF548s. And then you can see some matching and biasing networks, I think. So there's the output. So this will be the output match stage. Another RF component here, probably another amplifier. So where's the input signal? You can see some serious kind of thick current coming here. And this back part was in a can as well. There was a separate can here underneath. But it doesn't look like there's, well, there must be microstrip. You can see it here. So maybe these are the input signals. No, okay, so these signals come up through this board into this back section here. Anyway, very beautiful. Nice to see all these hand-wound toroids. I don't think there's anything on the back. So we'll leave that as that and move on to the next one. So the next one, what is this? This SGU 400. This is all machined aluminium on this side. So we're gonna have to attack this side. So taking the top plate off, we see a huge collection of screws to remove to get to the next layer. I don't know, what did we manage to see? We managed to see voltage regulators, I think, along the top there. An Altera, that's probably an FPGA, or what do they call them? CPLD, I think, when they're not as smart as an FPGA. I thought this was microstrip, but it just looks like bare sections of the solder mask. So that's kind of an interesting design. I wonder if that's just used as markings as where there is a trace underneath, and then they've left the solder mask off the ground trace so you can track the signal. I'm not sure. I didn't know you had to remove solder mask on the backing of microstrips. Anyway, kind of an interesting one there, not something I'd seen before or knew about. There is something really secret squirrel going on here, because it looks like I can see gold from underneath. So, and you know, the cutouts in the board, is that thermal reliefs or what's that for? But there's going to be something exciting there. But yeah, next, just remove all these screws and see if we can actually remove this board at all. I've already removed the SMA connectors. Although it looks like these are push fit SMA connectors because they're screwed in from this side. That's kind of an interesting choice as well. They don't look soldered. So I wonder if I can actually just remove those instead of removing the terminals. Anyway, we'll just take out all the screws and see what happens. Okay, it's free. Let's have a look. Oh, look at all those machined aluminium. And there is a daughter board there. What's that from? Oh, serial data. So that has a board interface. Look at all the gold on this. That's beautiful. There we go. It's not golden in there. I thought it'd be golden in there from the color. But I think it's just reflecting this board. Jeez Louise, this is a heavy PCB. What is that construction? Go on, Andrew, you can give that little scrape on the edge and just see if that's actually...
On this side? Or on the gold side?
Yeah, both. So just try and take some of the gold Oh, that one's FR4, yeah, by the look of it. Is that metal? Don't tell me that's solid gold. We're going to take this straight to the... No, I think that's like aluminium.
That looks like copper. It looks like copper on the end of this.
Well, anyway, very nice. We do have a little bit of digital. Oh, look at that. They've potted. No, okay. For a minute there, I thought they were being covert, but they've just put a heat transfer thing. Heat transfer pad. Oh, up there's quite nice as well. Wow, I'm impressed with the construction of that. It's so golden, right, doesn't it? It looks like something the Aztecs would worship.
You could put that on your wall.
Yeah, that's just really nice.
Yeah. Or do they just make it and never use it?
Yeah, there's probably channels, right? So that's clearly, yeah, there's components missing, but it's pretty bare. Yeah, there we go. I think it's just age. Can we see a date code on this thing? 1901? Do you reckon this is 2001? It's younger than I thought.
Still older than me.
Yeah, not me though. So that's the power side, right, with all the tants. Yeah, okay. Yeah. So there's the voltage rail generation. Digital section on the back, and on that side as well. That's the serial connector. And could you check what a V585ME30 is?
Voltage controlled oscillator.
Oh, it's a VCO. Cool. That was the SGU 400. I think we have another one of them.
Yeah.
Another SGU 400. And then we have a ref. I quite like the idea of the ref. I'm hoping it has some... I don't want it all to be machine construction like this because I'm never going to reuse anything out of that. But we might skip this one because this one is probably exactly the same. So we've popped the case off the other SGU and you can see that it's the same board revision. It looks like it's the same board revision, and even the beautiful bodge wires are identical between the two boards. So I think we'll skip that one and move on to the ref board, which I'm hoping has a load of discrete microwave components, but probably doesn't. And we've just hit this one and it's got two huge copper screws. What's that for? Do you think that's for tuning a cavity?
Or is it to bind it onto a huge heatsink?
So I was wrong, it was just a heatsink. Look at that though, that's quite cool. They've actually, what is it? They've installed a lug that they've threaded, and then they've had a copper screw that comes down. And yeah, they've used these standard, they're not mica pads, these are just thermal pads, right? Whoa, look at that guy. What is that? Ah, that's the crystal. That's a 10 megahertz crystal. So that's an oven controlled oscillator. So you'll have, but look at this connection. I mean, nothing says RF like 4 little bodge wires. So like 2 will be power, and 2 will be the, I imagine, the signal. So this might actually be, this might be the reference board. Yeah, okay, so it's Ref 400. And I'm going to steal that oven controlled reference. That's definitely coming off. That could be reused again. There was 2 things I wanted to capture. We've just got all the screws out, ready to take this out. I started unscrewing these SMA connectors, and then I thought, I'll try and actually remove one from the board, the previous board, but oh my gosh, they are in tight, and I just destroyed that. Just destroyed that. But you can see that launch. Oh yeah, look, they're split pins. So they are push fit connectors. But yeah, getting one out was an absolute nightmare. So I think the easiest thing is to just take the nuts off and then pull it out. So let's have a look. The big reveal on this board. What do we have? Oh, barely anything. At least you can see the signal path a bit more clearly here. Lots of filters. They look like pi filters. Inductor capacitor, yeah, CLC filters. But there's nothing in between them. So somebody really wanted to scrub these signals up. There's not actually many active components on here at all. Like I was expecting to see dividers then an amplifier or something like that, but we've got a few of these down here. There's your power supplies. So actually quite empty. Oh, and that's just the back of that regulator there. Oh well, I think on to the next one, right? On to the next one. So this is where we get to these shorter boards. This is the RX22. Let's pop the case off. Okay, so there's one cool thing to see on here. First of all, this board says AF gain for medical applications only. I'm not sure why they would reduce the gain by 12 dB for medical applications. I didn't even know you could use an NMR in medical applications. And when you pop the lid off, you get these nicely isolated sections. There was a can over this one, and so I removed that can and found another can. So whatever's in there, they really want to protect. Something really nice, the screws went all the way through, and it looks like these are removable dividers. So that was how the board was anchored down. They were using these very long screws. So we might actually be able to pop this whole board out. Okay, so flipping the board over, we found this extra can, the other side of this extra can, and then there's these LT, what is it? LT1028. There's some 74 series logic down here, but this section is extremely well shielded. But I'm gonna have to, use some violence to get that off. I don't know whether I want to just try and tear the can off or just get a soldering iron. Maybe get a soldering iron and pull that off. So managed to pull off that RF can, and I have no idea what I'm looking at. And then I have no idea what that is. Super weird component, but under 2 layers of shielding, and in a machine cavity. I mean, whatever that is, it's either emitting something that it doesn't want anywhere else, or it's extremely sensitive. I mean, I'm wondering what that thing is on top. Maybe it's a heater combined, because sometimes they use transistors as heaters. And you measure the voltage on the junction, you can use it as a temperature sensor as well. So that's a BD135.
Yeah, silicon NPN transistor.
Yeah, so I think that's the trick being used there. I think that's probably a heater. Maybe it's a crystal again. I also desoldered this to try and figure out what this is. It says MX3. I'm not sure what an MX means. And we'll take a look afterwards to see if we can find a data sheet for this one. But it kind of looks like an oscillator, a very big oscillator. So I think that's the end of this board for now. We're going to add that to the heap of PCBs and attack the ADC next. Hopefully we're going to find a really nice piece of unobtainium in there. Okay, taking the case off. On the ADC, we actually see the 2 inputs up here. Is this channel A? This is channel B. Okay, so this is filter channel A, filter channel B. And so then these are probably the ADCs for each one of them. Yep, ADC channel A, ADC, ADS even. It's an interesting name. What are they? AD7884 RPs. So we pull out the next board. This is the AQS, whatever that is. It looks like it's just some kind of processing board. We have a nice Intel i960. What is that? Is that 86 or something else?
Launched April 6th, 1988.
Right, and this is a 94 one. Still produced. We've got some soldered in kind of SODIMM and then an extra expansion. And then we've got a little board down here. It says AQX VME logic board. Is that soldered in? No, it's on a pin header. Okay, I'll pull that out without. Oh, nice, lattice semiconductor. So that'll be an FPGA. That's a cool little plug-in board. Yeah, I quite like Lattice. They're the only FPGA producers, I think, with a open source toolchain that they help develop. There's some reverse engineered ones for kind of the other manufacturers, but yeah, that's quite cool, hey? These are getting quite easy to pull out now because there's no machined aluminium on them.
Yeah.
Maybe we can remove that from its socket as well.
It's cool, literally just an old computer.
Right, let's see if we can get the next one out. We can have a look at the back as well. Oh, another Intel i960. Gradient control unit, this one's called. At least they actually say what this is. God, they're quite hard to get out. Do you want to shout out? Do you want to shout out for being the cameraman now? Yeah, no. Like, share, subscribe. Gotta get those views, man.
Comment, subscribe to my Patreon that I don't have.
Yeah, exactly. All of those hundreds of people looking to find out what's inside NMR. I am being an absolute brute with this thing and it's not coming out.
It's all screwed in.
It must be. It must be. No, I can hear it clicking on the thread. I think it's just these connect. Ah, there you go. There's another one. Look at all these chips. GAL. Why do I know GAL? Oh, that's old style, right? Look at that.
Yeah.
Right, the next one's the same. It's unscrewed, but I think it's just these plastic connectors on the front.
Has it just gone brittle?
Whoa, yes. I think some of the plastic's definitely gone brittle. Look at that. Actel, kind of 2 daughter boards.
Bruker, that was made by...
Yeah, that's their custom silicon.
Yeah.
I look some lattice FPGAs again. PLDs or CPLDs. Are those socketed? No, that's socketed. That's socketed, yeah. With a low profile socket. Oh, and I've bent all the pins. Should we see if we can get this last one that I thought was the thermocouple control board, but it's clearly not that. This one said TCU, and I thought these were thermocouple connections, but they're actually, they are little mini coax connections, absolutely tiny. Okay, yeah, thanks for capturing this one. So when you pull these up, they lock.
Oh.
But they spring unlock. What the hell? So when I was pulling these in to kind of remove these cards, I was actually locking the card in place. I don't know why. Why would you make something that automatically unlocks? It's just gonna fool somebody like me later. Anyway, look all those connections, all of these terminating resistors, right? So maybe it's a bus, and these are all the bus drivers. Oh, this is an old style computer routing. This is the old style auto routers. Sorry, what are you saying? An Intel? Yeah, but this time soldered in.
Yeah.
So maybe they switched to soldered on.
But it's just got the straight up and down routing, like a very old auto router.
Yeah. Still don't know what a TCU is. Whoa. What have we got locked down there?
That's a processor.
Yeah. There's a... What do you reckon? 486, 386. Whoa, what is that? Have you ever seen a processor like that?
No, I'm trying to work out who's the manufacturer of it.
IDT.
IDT.
There's another lattice, 2 lattice FPGAs. CPLDs, a lot of those hanging around. Okay, you ready? Oh, look at those fans. We've got some OnlyFans content. Sorry. That's going to get cut in the edit. So this was a breakout board. I thought these 2 cables coming down here were somehow connecting to this rack, but they're not. They're just
Is that all serial connections?
Yeah, it looks like those are RS232.
TTY.
Yeah. So TTY is the normal thing for a terminal.
Yeah.
Teletype terminal or something. I don't know. Something like that. Actually, the bit I was excited about was this. I'll tell you what, I'm going to take this out because I want to have a look at this now. So this looks like something to do with the flow control. Oh, look at this. Wow. You know, speaking to one of the rocketry club.
I could do with one of them.
Yeah, distribution blocks, solenoid valves. That's absolutely getting reused. I think that's for compressed air, you know? But that's such a useful thing to have. Cool.
Those huge resistors there.
Those are inductors. So I'm wondering if that's just...
Inductor, capacitor.
Yes, it's an LC filter. And it'll be because these are big magnetic coils, so switching these. So maybe they're somehow filtering out those. And these will be transistors, I guess. IRL, international rectifier.
IRL.
Z14, so probably.
Yeah, that's some...
MOSFET,
might be MOSFETs or IGBTs. In fact, I think I've got a bag of them upstairs.
So there'll just be a little bit of logic to... This will be 74 series logic. Yeah, SN74HC, so these will be driving the gates, and that's it, really. And so, yeah, like you said, some filtering to stop these guys, the switching of these guys filtering over to the rest of the system. Okay, I think we'll pull out the thermal unit. Oh, another one of these sticky ones. Oh, great. Another gas valve, but with many valves on it. Look at that. So gas in, gas out. So you'd think that would just be one valve, but look at it. We have 4 valves. I wonder if that's some kind of lockout. Do you know what I mean? Like they want, it's a pressure regulator. What's that? Gas in, pressure regulator, and then they have 4 connections, but it doesn't seem to go anywhere, right? It just comes forward. Do you think they have some kind of isolation thing? Like for safety, you have to trigger all 4 of them? It seems a bit crazy to do that mechanically, right?
What's that bit?
So this is a standard PID controller. So you see urotherm. So you use this, you can see what's happened here, right? They've wired a thermocouple in. So this is a thermocouple connection. You have to have compatible metals, the same 2 metals that your thermocouple's made of. So that's on there. So these feed straight into this. So this will monitor a temperature, and then it'll actuate a heater. And it looks like they come out from here, go in the board, and then they probably come out this way.
There's a very big capacitor there to be worried of as well.
Yeah, but I think that's only like 20 volt, no, 100 volts. No, what's that saying? It says 100 watt volts. What is a watt volt? Soldered across it is a bleed resistor.
Yeah, there's a bleed resistor that someone's added on afterwards.
Yeah, so no expense spared, right?
Yeah.
No expense spared. Well, do you want to have a look at the danger danger
look
box?
at the danger cupboard then.
The danger cupboard. That's a good one. Finger screws.
Almost like they want you to go there.
Yeah.
Whoa.
Oh, look at that
You
toroid.
can see that huge toroid in there.
Do you reckon that slides out? Do you reckon that's kind of... There's no way that slides out. That'd be nuts. I think that's going to be screwed in from the rack at the bottom. But that is a nice toroid. You could build an inrush current protector. So, yeah, it could be just, it presents a resistance.
Massive inductive load there. So.
Yeah, exactly. So it presents so it could be that as well. Yeah, but at least in the amplifiers I've built, you have one of these. You have some way of protecting from the inrush, and you might also isolate the ground. So
then you've got a huge bank of fuses behind there. You've got
rectifiers. They're pretty metal. Look at them. What's that kind of logo?
KBU power control.
Whoa. So V in up to 264, 400 watt. Out 48 volts at 8 amps. Just looks like a big power supply. I don't think there's going to be anything interesting there. So, but a classic thing, right? Look how big, look at that. Look how much rectification there is. There must be a lot of taps then.
Are they in
oh, look how many taps they have on this transformer.
Yeah.
Holy crap. Yeah, so they'll be rectifying.
Or are they...
No, I don't think so. I think they'll just be doing loads of different voltages.
Yeah.
Like, what are these rated to? 40 volts on that one. 40 volts, 40 volts, 40 volts. All of those are 40 volts. And then the black ones are 50, 63, 50. So I think they just have tons of rails, tons of independent rails. Kind of crazy, right? How many taps do you need? Yeah, that is the craziest number of taps I've seen on a toroidal. Okay, so we're not taking a break. We're going to just finish this. At the back of this is the top rack. So we've gone back to the top rack. Another huge toroidal in there. Let's go through this a bit quicker. Whew. Artisan. They're a famous, I've repaired one of those. I think I repaired an Artisan supply for an oscilloscope. So it just looks like a multi-output, 350 watt power supply. Some nice kind of padding at the back here. I've never seen that kind of before.
Foam or is it solid plastic?
I don't know. It actually feels like plastic, sheet plastic. So I'm guessing those are high voltage traces. And they decided to get some isolation there. But another kind of golden power supply, that's quite nice. I'm hoping this isn't a multi-tap toroidal. The other one had probably way too many taps to be useful for anything else. Ah, look. These are the taps of the toroidal.
Huh.
And then they come into the back of these other supplies. That's just...
nuts.
Yeah, insane, right? Well, okay, we'll have a look at these then. So this one, I'm just expecting more rectifiers. There is nothing to that board. So I'm guessing that's just going to be the same here, right? Another rectifier board, more fuses, more heat sinks. I'm wondering, is there anything underneath?
Yes.
Yeah, so they've mounted them up from below. Okay,
What are
that's
they?
cool. Those are
More
bridge
diodes.
rectifiers. You can see, I don't know if you can
more
see.
rectifiers, yeah.
Yeah.
I didn't get it on the-
I think this whole thing is just one giant linear power supply. And that's why I was kind of a bit surprised at the switching power supplies being in here, because they're pretty noisy. But look at that output filter. See, look, this just provides, what's this providing? 6.3 amps. Another metal plate on the back for the switching power supply. ACB standard board. Keyboard, SBS bus.
Keyboard, is that part of the computer?
It says display data out.
Yeah.
So maybe it was run like an old terminal.
It'd be interesting to tear down this at the bottom as well, see what these like spay terminal.
It just looks like a riser board. Again, they've offset. I think the switching power supply was here, right? Wasn't it? Yeah, I think the switching power supply was here. So it looks like they've brought it up to meet the switching power supply, but that's just seems like a waste of
And
money.
there's all these right down at the bottom here. There's all these just holes.
Yeah, it looks like they could solder in some extra connectors if they needed. Bit of a weird one. That board looks like a development board more than it looks like a...
Yeah, it just looks like perf board.
Yeah, exactly.
So
We've pulled out the last rack, the top rack, and took a look at the fan. The fan's kind of interesting. They chose to distribute the fan power using this circuit board on the top, which is kind of crazy, right? You think they'd just use power connectors. That's a filter for one of the toroidal transformers, which is over here. And what you can see, this is a 1000 volt amps toroid. Yeah, let's see if we can get this. And there's two of these. Yeah, this is 1000 volt amps, but they don't tell you what the individual windings are, so I'm wondering if I can get a data sheet on that one. But suffice to say, there are a lot of individual windings on this one. And I've just unscrewed all of the cables for the bottom rack, so we're going to go through what's inside the bottom rack next. This was quite nice, actually. So, this terminal distribution block. So yeah, you can see TTY. I mean, I use the Linux terminal all the time, and I know these TTYs exist, but it's nice to actually see them physically. Just a ton of serial lines. That's the distribution block for it. Oh, sorry, I should get a video of Andrew. Thanks to Andrew. He's been helping me out with this teardown. Cool. Yeah, he's been being cameraman at times and laughing at my jokes. So,
Cool.
Right. Shall we? Yeah, we'll pull out the other cards, right, and lay them all out. Ah, that's a 16-bit DAC. High-resolution DAC, HR DAC. You can sometimes have DAC split in two, so you'll have a low-resolution and a high-resolution DAC. As in, they overlap to 16-bit DACs to get, 20 DAC or 20-bit DAC. But yeah, there's two of those, right? 16-bit. Okay.
The same?
So these must be the DACs. Yeah, they are.
Yeah.
They are the same. I wonder what the DAC is. We've got to look at what the DAC is already. Can't wait. Looks like it's just on this daughter board. It might even have a nice voltage reference on there as well. Ooh. Burr Brown. So they make really nice amplifiers and DACs. So a DAC 70.
Around? Are they gone?
Yeah, they're still going. That'll be a nice DAC. That actually looks like it is a UV erasable EEPROM, because you can just see the sticker. There's a little circle underneath it.
So by peeling the sticker off, we're going to erase it.
You normally have to put a lot of UV in. I mean, yeah, don't.
Yeah.
Yeah, there you go. Look at that. How cute's that?
Yeah.
Should we get that? It's got a macro mode. It might not change into it though. Yeah, how cute's that?
That's cool.
Wow, it looks like a lot.
These look all the same.
Yeah, there's a lot of channels here, so you can see this is.
Yeah.
But I mean, they have what, one DAC, or do you think this is like a 16-channel DAC or something like that?
Well, it multiplexes between.
But yeah, then it would need a sample and hold circuit on here as well. That might be that, and that might be what these are or something. So you're right, it could multiplex with a sample and hold. That's pretty nice. But what have they heatsink? Oh, it's all of these guys. So I wonder what these guys are. They're five pin devices, LM81875. They might be. What do you think?
That sounds like a voltage regulators.
Well, the problem with the LM stuff is everything starts one, LM1.
Yeah.
I mean, they could. I would imagine
remember
they're
seeing-
output amplifiers, and the reason being, this is a DAC.
Yeah.
So you're going to drive And it could be a current, could be a voltage DAC, probably a current DAC. And so these are probably driving amplifiers that are used to drive the outputs. So we just pulled this out from here. Just seems like this is some kind of compressed air accumulator, something to buffer, you know, releases or whatever and maintain pressure. It looked like it was on the incoming air and it was connected off a T-junction to the regulator that's out here. So I think it was just some smoothing. We've got this power cable. I think that just goes, yeah, that actually went out the system. It was cut short. And then I think it comes back in. I think it came back in here. So some kind of random cabling choices there. So we'll just put that in the pneumatics section. We pulled out the bottom rack and we pulled out all the remaining cards out of it. The bottom rack's over here, so you can actually see how the toroids are before you try and take them out. This is a bit less of an interesting back panel. You can see it's kind of quite standard, a few power connections, but it's not like the other one. And what about the other side of that back plane? Yeah, I think that looks to me more like a VXI rack. If you've ever seen inside a VXI rack, they have these two connectors, one after the other. Although I've never seen one with a front and back, and a front and back connector. That's new to me. So there's a few cards we pulled out. I thought this was the computing card. Fairly uninteresting. Big set of header pins there, so you can add a daughter board. But there was no daughter board on that one. But that was in the first slot. Wow. A lot of horizontal routing on that one. So yeah, I don't think there's anything interesting there. We've got what, an MC, so a Motorola 680306. This one looked really interesting because, well, okay, apart from these unpopulated parts, there is a huge chip. Oh, it's not a chip. Okay, it's just a can over an amplifier. But yeah, okay, that's maybe not so interesting anymore. It's just essentially a glued-on amplifier stage for this HTX. And then we took the screws out the back of these two. And again, we have that same construction with the aluminium kind of poles, dividers. But I'm not sure what's in here. So this one says BSMS lock receiver 300. So I'm getting, this is a locking amplifier. What do you reckon? What are these? Are those Intel? Is that Intel's logo? Or AMD?
AMD.
Is that AMD?
Yeah.
Yeah, AM27C256. Again, you can feel the little dip in there, which tells you it's a UV erasable EEPROM. Nice to see AMD in here. We've seen everybody else. Cool. And I think that's it, right? We looked at that one already. I think that's the works, isn't it? Is that everything? All right, thanks. I'm going to leave this pile of parts here. If there's something you want to see that you thought was particularly interesting and I skipped over, let me know. I'll hold on to them for a few weeks before I actually start tearing them down for some more of the parts that I want, mainly the gas fittings and stuff like that. But thanks for joining us and see you next time.